started, the camera is recording both fairly simultaneously just for convenience there. Double check that they are both recording. And by the way, you should do that double check that they're actually recording again once you actually put them in the water, because it's easy while you're screwing around with the calibration and everything to accidentally bump something and turn the camera off, and then it's really annoying when you pull it out of the water after 2 hours and find that you weren't filming your fish. So always try and remember to double check that right at the last possible moment. Now we're going to film just really quickly the sight is, and I'm going to flicker an LED light a few times on and off in front of the cameras, and that's what we're going to use to actually go down to the 1/30th of a second or 1/60th of a second level of synchronization. So that's done, and now we're ready to actually do the calibration. Except that before we do that, I'm going to take a look at exactly where I'm filming the fish, which is right over there, and think about how I'm going to place this arrangement up against that log, and then how the cameras should be positioned on this little rod, given where I'm putting the log. And I would say the way that log is facing, it's going to be easier if I sort of twist my cameras like this. And it's important to do this camera repositioning before the quadrat calibration. Otherwise the quadrat calibration is completely worthless. So, this is the time to do this, and I've just got little wing nuts here under the cameras that I can loosen, set this thing properly. Separate calibration steps. One is with this checkerboard for correcting radial distortion. The idea here is that this board, all the lines in this checkerboard are perfectly straight, but the camera lens has a little bit of radial distortion that sort of makes a bulge in the center. And if we leave that alone, it messes with the 3D geometry pretty badly. So what we do is we've got in the VidSync application a feature that lets you go through and kind of click on a bunch of corners of a line that should be straight, and in the video they're going to be curved because the camera curved them. But because they're curved, we can measure that curvature on the video and then figure out what the correction factor for it is. So we're going to try and film this thing now so that we've got it close enough to the cameras that it takes up the full view, because right around the edges of the image is where that distortion is most noticeable. So you want it to take up the full screen, but you also have to have it far enough away that it's in focus. If it's up really close and full screen and blurry, then you still can't pick out those corners really well. So this turns out to be just about the right size definitely for my camera.
There's a lot of, the sun's not really, the sun's shining on it.
Not worry about it too much.
Okay.
You get the idea pretty well. I'm just holding it here in front of the cameras, and I do each camera individually, because this is a single camera thing. You have to do the distortion correction for each camera by itself, and try and get it sort of as flat, as straight on as you can. I'm switching to the other camera, and I just sort of know from experience how far away the camera needs to be. You also want to try and hold these two as close to exactly still as you can, just to minimize any motion blurring. Although stillness is not quite as important for this step as it is for the next step. Ruth, could you hand me take that and then hand me the big quadrat? Thanks. Now this is the quadrat calibration box that we use to actually do the 3D geometry, which you can read about on the website. And it's really important to get this as still as possible relative to the cameras during the calibration. And the reason for that, apart from wanting to avoid any motion blurring in the image, is that you've got a little bit of a synchronization error between the two cameras, even if you synchronize it based on that flash, because the camera takes images once every 30 times a second. So you've got about a 1/30th of a second interval that you're working with, and you can only get it to within the nearest, I think, half of that interval, so within the nearest 1/60th of a second. So however far this system moves in 1/60th of a second is how far you're going to have sort of an unnecessary error between your two cameras in your calibration. You have those kinds of errors every time something moves around when you're measuring it too. So all the moving fish and everything have those tiny errors, and that's one of the main sources of the small error in those measurements. The important thing for keeping it still during the calibration, though, is that, you know, an error in the calibration is going to affect not just the one measurement, but all of them. And there's no reason that these things have to be moving. So just be careful to keep them really still. And again, I kind of know from experience how far these things have to be back. I want to get sort of a straight-on shot where I can see all the dots on both surfaces of the quadrat in both cameras pretty clearly, and while it's sitting completely still. So I just try a few distances just to make sure I've got exactly the right thing. Alright, that should be good.